Okay, class. This week our software quality module um, is on software inspections and software quality inspections, and specifically code reviews from a construction practice standpoint. Um, I start here for a few reasons. First is we're going to cover quality reviews in the large. The first half of this is going to talk about inspections throughout the life cycle because these are important for several types of software that one might build. Reviewing your requirements, your design audits, your procedures, process audits. These things can be very important, particularly in specific domains of software engineering, healthcare, getting FDA approval, for example, in military systems, in contractor-subcontractor relationships. So we'll talk about it in the large. But then I'll switch and we'll talk specifically about code reviews. And I lead with code reviews in part because no matter what else we talk about this semester, research and practice has shown for the past 3 decades plus that code reviews are the number one quality improvement technique for your source code. No matter what anybody else talks about, automated testing, unit testing, we're going to talk about static analysis, all these things. Now, is it the most cost effective is debatable because it takes a lot of human effort to review code. But what's not disputable is if you want to write the greatest quality code, you simply put more eyeballs on it. And so that's what today's talk is going to be about. Okay, so here I want you to consider these inquiry questions. Take a moment, pause the video, think about reviews or inspections or audits that you hear about in everyday life. Not software ones, not things it's at ASU or something like that, but in everyday life. When do you hear about reviews, inspections, and audits? And then think, who does these inspections and audits, and what is the relevance of who does it? Okay, what documentation is made of the inspection? What record, and after, is there some kind of follow-up that's required, and under what conditions? Okay, take a moment and please pause and consider those questions. Okay, so hopefully you paused and come back and you thought about these things. Some discussions we've had in the past with some of my classes on these questions. Reviews, inspections, and audit you hear about in everyday life. A common one is a vehicle emissions inspection, right? And what do you do when you have to do an emissions inspection? You have to go to an emissions testing facility of some kind, and that's done by whatever your state's Department of Motor Vehicles is normally, and it's relevant. That's a state agency, which means that they have the power to issue a certification, right? A passing of the test. You get a piece of paper. If it says my car passed the test, you get a sticker that you normally put. In Arizona, we put them in the corner of our license plate so that the cops know, hey, this vehicle's been inspected for its emissions. In New York, when I lived there, it was in the front windshield. I remember you put when I was a kid, you put it on there, and there's a little month and year saying how long that's good for, right? And does it require a follow-up? Yeah, one time I had a beater car that didn't pass vehicle emissions. I had a temporary 30-day pass to go have those emissions things fixed at a shop and then come back and get retested. So there can be a follow-up activity. Likewise, you hear about that word audit, right? We've got tax season coming up, so you might hear about getting audited by the IRS, right? So again, that's a federal agency, right? And it's a type of formal review, and it's relevant that it's done by that agency, right? Even if you go to an accountant, the reason why the accountant has to sign your tax form with you is because if you get audited and perhaps have some problems with the audit, that accountant may lose their license as a CPA or whatnot. And again, if you get audited, is there an activity that requires a follow-up? Well, it kind of depends on what they find out in the audit, right? And then the final one that's relevant to ASU here is the degree program just underwent an accreditation, and that accreditation is a formal visit. We had a whole team of accreditors come to this campus. Some of you, maybe in this class, I don't know, actually talked to some of the evaluators remotely via Skype one day. That was done by the ABET is called the group, and then they have subcommittees underneath them. They are an accrediting agency. Okay, they write a whole report. That report's not due until July. We're actually in the middle of a back and forth with them. And does it require a follow-up? Well, it depends on what the results are. We could have a 3-year follow-up or the standard 6-year. Okay. Anyway, all different kinds of inspections or audits. You hear about these things every day. So what does this mean in the context of software engineering? Okay. So in the greater context, I want to talk about a software quality review. Why are they needed? When do you do them? Where do you do them? How do you do them? I mean, even who does them? I should have a who up there, right? Who does the reviews? Okay. Some of your supplemental readings and required readings for this week give you some definitions of a software quality review. Kyle Fell's 88 report for the Software Engineering Institute specified a review as a critical evaluation of an object. Critical meaning, it's evaluated from a critical context. Meaning not only is a rating or a score given, but there's some critique, some evaluative language used against that object, if you will. An object here would mean some kind of software engineering artifact. Fagan's paper, which is the one that is required for you on formal inspections, uses that kind of language, right? Right in the paper it says inspections are a formal, efficient, and economical method of finding errors in design and code. Formality suggests something, right? Something with a lot of pomp and circumstance and ceremony to it, which, by the way, isn't very agile, which we'll talk about. But he also uses the words efficient and economical there, and that's debatable when we look at formal code reviews, and that's somewhat at the gist of the argument about how much formal review will you actually do to something. The IEEE 1028 standard on quality reviews gives us a bit more complete definition: a process or meeting during which a software product is presented to project personnel, management, users, customers, user representatives, or other interested parties for comment or approval. Well, so in a sense, we've actually used the term review already in our Agile language, right? In our Scrum language, we talk about the sprint review. And in the sprint review, all the chickens get to come, right? The pigs are there because they built the thing, and the product owner is there to evaluate the sprint goal, but also the chickens are there, right? Any stakeholder that has an interest can attend the sprint review. Okay, and these project personnel, management, users, customers, these are all the chickens that we're talking about, right? In Agile terms. It's also interesting that it actually uses the language process or meeting, right? A meeting means that what a meeting suggests is that it's a synchronous activity, that everybody's there, co-located in some sense, and able to give that feedback and approval in synchronous time all together. Now, it says process or meeting, which means maybe it's done asynchronously, kind of like how you have to do it in an online class. But still, there has to be some convergence point where the comment period ends and the approval period happens. This happens when I submit academic papers for review to conferences or journals. I both do that, and I also serve as a reviewer for conferences and journals. And that entirely that's a workflow that happens asynchronously. I get emails saying, please go review this, give your vote. There'll be some discussion between the committee, but we never physically get together usually. It's usually all done asynchronously. So it's possible to do asynchronously. Is that the best mode of feedback? Is it the best mode of review? Debatable. But again, sometimes asynchronous is the only economical choice that you have. Okay, so let's delve into some of these questions. Why are reviews needed? All right. Well, first possibility is as a supplement to testing. We started with unit testing. We talked about how path coverage and exhaustive testing would be the best kind of testing you could do because you're basically testing every possible use you could have of the software and every possible state it could be in. However, we also talked about that's a computationally intractable problem. You could never do all that amount of testing. So since you can't test everything, and also because testing does not necessarily find all types of quality issues, right? Even when we do white box testing, we're only talking about that executable code. I also mentioned in those notes that the nature of a defect, we talked about failures, faults, and errors. And remember Watts-Humphrey definition. Anything that requires a change to the code can be considered a defect, even if you're changing a comment, right? Even though that wouldn't affect black or white box testing, because you don't execute comments, right? But it is a maintenance-related issue, and Humphrey will call it a maintenance-related defect, and testing is not going to find those kinds of things, whereas a code review will. Okay, data is shown. I'll show you more data in a little bit. That code review is going to find roughly 2/3 of latent defects, whereas testing is only going to find a little less than a third, according to a relatively recent study by Capers-Jones. So I'll talk a little bit more about some of the data associated with that. A second reason why reviews may be needed, a communication vehicle, right? When you're testing things, now we talked a little bit about, do you test your own stuff or does somebody else write the test for you? Somebody else writing the test for you is a way for them to have to learn about things. We talked about that in the pros and cons. In reality, though, that's kind of a bit of an expense, if you will. Whereas if somebody's reviewing your code, having to go in and read your code in some sense, it is an excellent communication vehicle about what's going on, right? So you're communicating quality and status to stakeholders. Sometimes, I've had non-technical people go to code reviews. At least if you're communicating the results of the code review as well, you're making some communication to those stakeholders. But you're also communicating quality and design information to peers. And by design information, we mean low-level design. It's almost like a training session, or that's the next benefit, is a training vehicle. When you sit through a code review, you may pick up on some different ways of looking at and different coding idioms, as they're called, low-level coding patterns, for how to solve common problems that may come up in coding all the time. Something new about an API, something new about the structure or call sequence of code. So the more you work in code, the more you read others' code, the more you learn yourself, both how your code base works as a team, as an organization, but also you may pick up on some best practices. That's why, in some organizations, as an aside, code reviews, it would be kind of thing where, well, if that's a senior engineer who's been writing code for a long time, we need to get other senior engineers to review that person's code because it's probably going to be very sophisticated about the system and the junior engineers won't understand it yet and blah, blah, blah. And I don't believe that at all. A code review should have all levels of engineering, because even the junior engineers, first of all, they can always pick up on something as a different set of eyeballs. But secondly, they're going to learn more by going to those kind of code reviews as well. And we'll talk more about that. But let's motivate why these reviews are needed. And let me talk a little bit more about some of this data. I'm going to try and use a pen again. Let's see if this actually works. If you look at this data through this line, right, here's our unit tests and other kinds of tests. These are all different kinds of reviews: requirements review, top-level design review, and so forth, all the way into code reviews or code inspections. Well, look at this data in each column, the low, medium, and high in the distribution of data that was done on the Capers-Jones survey. This is 2008, still recent enough. And by the way, these kinds of studies have been repeated in software engineering for 3 decades. These results are consistent. Even the lows are generally higher than these lows, the medians higher than these medians, and the highest higher than these. Okay, so in general, doing these reviews finds more defects. That's ranges of defect removal efficiency. Defect removal, before you remove defects, you have to find them. So the term is defect discovery. All right, we're talking about, as an aside again, when we talk about failures, faults, and errors, and we talk about some of the quality terms or language that you would use defect injection. Trying to write neater on this thing. Defect injection is the moment at which the defect is created, meaning literally when the developer's fingers are on the keyboards typing in something, or the business analyst typing in a review, or you typing in a user story, whatever the artifact is. Defect injection is that moment in time when it was injected. Now, of course, you may not, one thing the tools try and do is they try and help you catch a defect as soon as you do it, right? That's why we have syntax coloring in IDEs like Eclipse now, right? And all these hover tooltips saying, hey, this isn't right, because you're trying to narrow the gap from defect injection to defect discovery, and you're trying to find more of your own faults as well, that you more of your own errors that you introduce. So the delta between these two in time equals dollars, right? If you inject a defect one day and you find it a week later, think about all the work you did over the last week that may have depended on that defect's and now you have to go rework not only and fix the defect, but maybe you got to fix other things that you built on top of it. And it goes like that in software engineering. The cost of defect removal, kind of the classic curve, is exponential, meaning as a defect is injected here, the cost as time goes on of fixing it grows in this exponential curve, meaning you want to find it, you want to narrow that as much as possible. Then once you discover it, then you have the defect removal. Right? That's the actual act of getting rid of the thing. Okay, so in this case, what they're talking about in these slides is really your ability to discover and whether or not those things help you remove, together. Okay, so that was a little bit of an aside. Okay, so anyway, data clearly showing that reviews are better than tests, okay, at helping us discover and remove defects. Okay, now another thing it tells you is together, right, these numbers together are better than any of these individual numbers. So even though you might say, well, we may get on average 60% of those defects. We saw 65% before, but 60% in that ballpark for code inspections, and we get, say, we talked about unit tests might be 25%. You might say, well, that's diminishing returns. How many defects are we going to find with these things together? Well, if we do all these activities, the cumulative efficiency of 97%, right? We found 97 out of every 100 errors. I mean, frankly, we need to be better than that, but that's at least a good starting point. Okay. Now, if we just showed in the previous slide that inspection reviews are the number one quality technique, at least they're better than testing, then take a look at where developers spend their time. So there's a paper in the Cascon Canadian Software Engineering Conference in 2010, and this researcher found through a survey of a questionnaire saying, the actual reviewing of each of others' work is about about 1/6 of the people indicated that was a significant. The question was really what do you spend time on? And so they read documentation, they look at source, they write code. I mean, you've only look at this the first three before you even get to writing code. Where they spend 50% of the time, attending meetings. But actually, only 1 in every 6 answered the survey saying reviewing others' work is a significant work practice at their place. And this is the rub, all right? Why is it that we have something that we know? I mean, studies have repeated that this is the best thing to do to improve the quality of your code, yet it's not on the top of this list where developers are, saying this is where I spend my time, right? Why are these kinds of things happening? Okay. The answer, and we'll talk about it in the code review, by the way, is dollars. All right. Inspections and reviews just cost a lot of money because they cost a lot of time. Okay. That's the main reason. There are other reasons we'll talk about, social pressures and the like, but the main reason is it simply takes a lot of time. So what Fagan said about being efficient and economical, very much up for debate. However, what's not up for debate is this is going to be, if you had to pick one, if you were emphasizing the dimension of quality, all right, often we talk about something called the iron triangle, the triangle of quality of something, the cost of delivering it. So this is your dollar sign, this is your quality, this is your time measure, and there's kind of a maximum that says you can only optimize 2 of these dimensions at a time, not all 3, because as you let's say you want to improve quality in this direction, well, then your cost is going to go up. All right. If you want to actually, so will your time as well. This whole triangle gets bigger. If you want to reduce your cost, then you have to spend less time, but then you're going to be sacrificing quality. Okay. These relationships from a project management perspective suggest that, yes, it's the best quality technique. If I want to optimize this dimension and I didn't care about how much time I spent, how much cost I had, then sure, I'd sit there and review all the live long day. As another aside, a study back in a couple decades ago now, but folks looked at the burden of the software process that was adopted for military software. I don't know if you're a vet or if you work for a defense contractor. I know that's the first job I got starting out of college. I worked for a defense contractor in the Washington, D.C. area. And at the time, I think I've mentioned things like SCRs to you and so forth before. At the time, we had some military standards. I remember numbers like 2167A and 4198 that gave us all these processes around software and doing inspections and reviews. In any event, the given the heavyweight nature of the process, what was considered a standard work rate for a developer per day was to generate 8 lines of code per day, per dev. Now, if you go anywhere near a military system and the sophistication of the functionality, you know there's a lot of code in there. Hundreds of thousands, millions of lines of code in some of these systems. How are you going to get there in 8 lines of code a day? Really big team? Yeah. Very costly? Absolutely. I mean, I'm telling you to give me in a class, the first sprint was 150. Now I'm telling you 300 lines of code a week, right? And most dev shops, you're doing this. No, you're going to be, that's even just for a student. All right. So again, I can produce, really high quality lines of code per day at that rate, or I can try and move faster. How much quality am I going to sacrifice? That's really what we're talking about. Okay. Enough on that. Now, when do you do reviews? Again, I want to point out our focus is a bit on code reviews, and I understand that. I put up the RUP model here, but I could pick any of the software lifecycle process models that we talked about, because they all have those phases that we talked about at the beginning of the semester. The point is that every phase activity of a software engineering process has touch points in which they could introduce reviews. In fact, what I really should have went back to, if you remember or want to refer back to the notes on the original Agile Kool-Aid talk that gave a summary of lifecycle models, there was one in there that was the V model, right? And part of the thing of the V model is it was taking the waterfall model and adding this side. This side were all different forms of reviews, right? And they went with each kind of phase activity, requirements, design, implementation, and there was a review on each side, right? So the point is on each one of these phases, requirements, reviews after stakeholder touch points, meaning we just, stakeholder touch point might be we executed a survey, we did an interview, we did some ethnography, all these kinds of requirements elicitation activities that you're going to do in 415 when you take that course. From our perspective, it would be, hey, you're writing the user stories with the product owner, and that part in the sprint planning process or even the release planning process where the developers sit down and go through the stories and try and understand them, that's a form of review. All right. So when it happens might be dependent on your lifecycle model, but human review is often the case for software requirements. I'll also mention, by the way, that in requirements, and you'll again talk about this next year, so I'm not going to spend a lot of time talking about it now, but I will mention this is also where formal methods and formal requirements specs come in for requirements and analysis. Meaning that's when I use mathematical language to express my requirements, because I can actually put them through theorem provers, if you will, and mathematical resolvers to understand if those requirements meet the consistency test for requirements. Okay. Again, more for 415. Let me put that aside for now. But these are the kind of things in requirements and analysis. We're going to talk about the implementation part, our peer level reviews. We're going to focus with review with peers, which means developers with other developers. Test QA test scripts reviewed by stakeholders, and even when QA comes up with the test scripts, meaning functional tests, they're going to sit down and understand how to test your application. They have to have some understanding and review, for example, the requirements. QA test script writing very often results in a QA person going back to the business analyst and saying, I need to understand the requirements better because this doesn't make much sense to me, and is actually a form of review. And then finally, during deployment, our transition part of this course as well, the way software gets into the hands of end users is important, and that process requires review normally by the software architect or team lead, the project manager, and your operations lead or architect, or some different roles. It could be IT architect if you're writing a web or mobile, or it could be, you're the term systems analyst. And they'll get together, and those folks will start coming into your meeting sooner, so that they start understanding the assumptions you're making on the operational environment. Meaning, how many computers are you proposing, and how fast is it supposed to run, and how much memory is it supposed to chew up, and so forth. That's a form of review as well. Okay, so reviews happen everywhere. The nature of the review and the level of formality required is dependent on when. It's dependent on what domain you're in. Okay, where to perform reviews. You might think, what do you mean where? Well, what does that mean? Um, well, there is a social and cultural bias to where it happens. All right. So some reviews or audits, are conducted off-site in front of external stakeholders. Maybe you got to go to the customer site. If you work for a large defense contractor, you work for the Lockheed, Raytheon, General Dynamics, and folks like that. When the military comes in to conduct their design audit and probably brings in a third-party vendor to help them with that audit, sometimes they want to do that off-site. They don't want you in your own building, if you will, where you're too comfortable. In a way, they want you to be uncomfortable. All right. Or they could happen on site, but has to be in a formal meeting environment. All right. We need these facilities as part of this review, and your meeting planner's got to have the projection system, the ability for groupware, network connectivity, the ability to share secret, perhaps, information. Sometimes software is involved. Again, I'm thinking defense systems. The software itself may deal with classified information. It may be a classified system. So again, you may have a level of formality to the where as well. Other reviews, as we'll talk about, can be quite informal. It could happen at your desk, could happen up at the whiteboard, could happen in a conference room, and so forth. So the where can matter. And what we're getting as a foreshadowing, because we're going to talk a lot about this, is the level of formality. Formal reviews have a more burdensome, heavyweight process. Doesn't mean they're a bad thing, but it does mean that you have to plan for that level of formality. You have to understand it's going to take time, cost, physical environment. Whereas informal reviews, hey, if we have to do a review, you're saying a great thing, great. We'll do informal because we can go faster. It's less socially stressing. It doesn't require as much setup. Let's just get it over with kind of attitude. That may result in being a little bit too casual about your review, not having a process in place for follow-up and for improving quality based on it. So even though you're saving money, you're not finding and fixing as many defects because you don't have that level of formality. Okay, the different types of reviews we talk about. Your reading with the IEEE 1028 from 1997 talks about these different types of reviews: manager reviews, technical reviews, inspections, walkthroughs, audits. Your recommended textbook, which I said you don't have to you didn't have to buy, but if you have it, or you can go to McConnell's website and probably see a paper on it. Steve McConnell talks about the formal inspections, the notion again of a walkthrough, a code reading, or what's called a dog and pony show, which is somewhat like your sprint review. I'm going to use the taxonomy in your required reading from Wagers, Peer Reviews in Software. This is a book that Wagers put out. There's also a paper on it, so I'll give you that reading, and talks about this this level of formality to informality of inspections, team review, walkthrough, pair programming, peer desk checks, ad hoc reviews. Again, the key is granularity. How much stuff is being reviewed? How big and burly is this review, and at what level? Is it a high-level design, or is it down in the details of code? And the extent of the level of formality. Again, how formal a process you're going to have for conducting the review, where you're going to do it, who's going to have own follow-up to the items, and how is that all going to be specified and tracked. Okay, that's what we mean by formality. So let's talk about that. So again, we're going to talk about from this Wager's perspective of most formal to less formal. Um, Most formal on this side are things like formal inspections and team reviews, all the way over to the least formal peer desk checks, pass arounds, ad hoc review. Ad hoc meaning you make it up. So I'm going to talk through a few of these from the formal level through to pair programming to give you an idea. But again, more formality has shown, research has shown that it finds more defects, you have higher quality. Less formality, fewer defects found, fewer defects discovered, and less quality, right? So, and I should mention on here, this is going to be fast, so it's going to be less on the dollar side, and this is going to be slow and more on the dollar side. But the result is, again, that quality dimension, you're going to find more defects, you're going to have higher quality. And that's our primary concern. However, I want to remind, don't ignore the social issues. All right. If you've got to go into a meeting and stand up in front of a room of people and go through your code, it can be socially stressing, right? I mean, nobody likes having work put under a microscope like that. You're worried about what people will say. It can be stressful to go through that kind of review. But there are benefits to both the reviewee who's getting reviewed, and for what it's worth, there's benefits to the reviewer. All right, that you should overcome. This is going to be a learning experience, and it's, Fig and others have said, code review should not be the basis of a job review, if you will, a personnel review. You need complete transparency and honesty. If people are trying to hide defects and so forth, this is an issue. I ask that of you. I ask you to do your review and retrospective at the end of a sprint that includes a peer review. I expect, openness. What I get is a lot of students trying to tell me things that aren't true in their project because they're worried I'm going to ding them on that. Well, I don't use it as a basis for grade. I'm trying to get your feedback on how the team is doing, and getting you to have an awareness of how your team's doing so you can improve. But anybody who has to basically talk about themselves and their work, individual or team, normally feels some social stress associated with that, and kind of a burden to say, well, I need to paint a pretty picture here because I'm worried that somebody's going to give me a job performance review, a grade or something like that on it. If you have a good culture, one that isn't individually driven and worried about those social issues, what you really get is a quality culture, and that's what you want to have. It's the agile principle again of collective code ownership. We all own the code. We all are responsible. It's the same thing with the Scrum board. It's not about my task, your task. That's why I tell teams don't have user stories owned by one individual and all the tasks done by an individual. It's the collective responsibility of the team to execute and complete a sprint. It's the collective responsibility of the team to produce quality software, right? And if that's the case, then you're all in it together and you don't point fingers. You don't say, well, Joe screwed up or Susie screwed up. Oh, dang it, darn, it's your fault. You go fix it. It's the collective responsibility of the team to meet the quality threshold required of your project. Okay. This is kind of similar to your software lifecycle process overview. There are phases that are proposed for a basic inspection process. What is going to differ when I go through some of the examples of them is, how much time you spend in each one of these. So this is not a specific process slide. Don't read this as one of the actual review processes. Read this as this is a general sequence of phases that one goes through, and what we're going to talk about is the level of formality and when each one of these steps happens when I talk about some of the specific review processes. So overview, first is plan the review, cover all the logistics. Hey, if it's a formal process, you gotta, like I said, you gotta get the meeting room, display the groupware, yada, yada, yada. If it's an informal one, well, you still got, planning may be as simple as, calling over the desk of your bullpen and saying, hey, Susie, can you come over here and look at my code for 10 minutes? Well, okay, that's not a lot of planning, but it's planning. System overview presented to the inspection team. Whoever's going to come in and look at something, whoever's going to review, has to have some understanding of the context in which they're reviewing. Again, in a formal review, there may be material sent out ahead of time, design documents, requirements documents. Hey, we're going to go look at this subsystem, let's say, but here's the things you need to know about that subsystem before you enter the formal review. Or again, informal review. Hey, Susie, you coming over here for 10 minutes? Oh, you want to know what this is about? Well, I had to go write the logger feature for user stories 26, 27, 28. I'm trying to build a common logger. So can you come over here, and kind of just look at it? And boom, that's the overview. Code and associated documents are distributed to inspection team in advance so they can prepare. Level of preparation and whether there's even any. Again, Susie might say, yeah, give me a minute to go look at those stories again to understand where I'm coming from versus the formal review and how long somebody's going to spend reviewing these kinds of things. Then the actual inspection takes place. Again, formal audits can go on for a week or more. A desk check and Susie comes over for 10 minutes. So different length of time, but some action takes place. I mean, this is what we're after, right? That's the thing that we're doing. Now, based on, and this doesn't talk about enough, after the inspection meeting, if you will, or the inspection activity, the output here is some defects discovered, some errors discovered. And so the next thing is what needs to change? And we talked about the nature of change with our source code control stuff, and we talked about the nature of change and where it comes from. So from a quality perspective, the inspection meeting may result in, action items basically. That comes out and says somebody needs to do something, right? And, and like we talked about the nature of change, that could be simple as, yeah, Bob, you need to go off and do it because Susie told you what you did wrong. Or it could have a level of formality where, oh, that's a significant defect. It's post-release. It's in our release software, and I've got to involve that change control board I was talking about before I go make any of these modifications. So this modification or rework step, the level of formality of that also depends on all those things we talked about with the nature of change when we were talking through the change management lecture. And then finally, is there follow-up? Is there a re-inspection required as part of follow-up? Who's going to make sure that you went and did and corrected what you did, right? Is it required? Maybe Susie came over, said some things, Bob's got to go fix it, and there's no follow-up. There should be, but there isn't. Whereas in a formal audit, there may be an assigned responsibility of the contracted organization and even to the individual to say, you've got to go follow up and make sure that that's finished in the system and you got to sign off on it. All right. So all these levels of steps, and again, I'll use this kind of as a framework for discussing some specific examples going forward. Okay. So the first example is a summary. It's in Weigers, but it's really credited to Fagan in the IBM Systems Journal way back in '76. That talks about a formal inspection. So this is on the formal side of our the most formal side of our spectrum. First is it talks about the nature of the team. The team has to have at least 4 members, and they have defined roles. So you have an author of the code being inspected. You have at least one inspector, usually more. That's the person looking for the errors, omissions, and inconsistency. There's a reader who reads the code to the team. So even the first thing you might say is, well, wouldn't the author present? Well, maybe not. It could actually be, and in a formal inspection, it's somebody else. The reader who's actually kind of responsible for reading the code to the team. Maybe you got it up on a presentation. It's up on the presentation panel, and they're the one walking you line by line, saying, "Okay, let's go over this line of code. Who's got comments, who's got feedback, kind of thing." And then a moderator who chairs the meeting, responsible for actually running the meeting and noting the discovered errors, putting out the action items, need for change afterward. They may have help. There might be a scribe. There might be a chief moderator, depending on how many more people are in the room. This has at least 4 members. This can get up to a dozen people quite easily, right? In a formal inspection, there's normally, in addition to the code, some of the things that would be brought into play would be different checklists, a checklist of common errors to drive the inspection. You should recall your PSP, your personal software process from SCR 215 and perhaps 216, where Humphreys told us, even from an individual perspective, that you should have a checklist of the different types of errors that are common for you to make. So you should actually go in, if this is your code being reviewed, you should bring that checklist in and say, I often have a problem with some of my logic and the ands and ors, and I get kind of screwed up. Well, your reviewers should know that, and they should pay closer attention to that kind of thing. So that checklist can be programming language dependent, right? This is stuff in code, so it may depend on. So, for example, you may have a problem with memory leaks in code that you've written in the past. Well, if you're in a garbage collected language like a Java, the memory leaks can happen, but they happen in a different way and not as prevalent as a language like C or C++, where you're responsible for allocating and deallocating memory resources off the heap. So these kinds of things can be programming language dependent. The weaker the type checking, the larger the checklist. What does that mean? Type checking is a feature of a language, right? So you took your languages course by now, you should have, and you talked about hopefully the notion of type checking. Strongly typed languages provide more information to the compiler regarding the type of data that it's looking for in any variable or anything else like that. If you're in a weaker typed language, not so much. So typically, interpreted languages, scripting languages, are much more weakly typed than compiled languages. So, for example, Lisp, JavaScript, Python. Python's is more strongly typed than, say, a JavaScript. JavaScript, very popular web development. We talk about it, but you can do all kinds of things due to the lack of true type safety in a language like JavaScript, and they're trying to fix that, by the way, in the latest versions of ECMAScript. Whereas compared to a language like a Java or an Ada, you have more protection from the compiler. So your checklist tends to be larger because you'll tend to have the potential for more errors that are not found by the compiler as part of a weakly typed language. I'll give you an example. Casting errors. Right? What's a cast? A cast means you're trying to convert a piece of data from one type to another type. If you're in C, you joke around. I mean, you could create something called a void star pointer, a pointer to anything, any data type you want. You can freely cast between different types, and very often casting in old days of C compilers would have undetermined. If you look at the back of the white book, the K&R book, just hey, if you cast from this to this, the behavior should be this, but it's really kind of undetermined, undefined, right? There's no requirement on the compiler. If you contrasted that to a language that I'm sure you're not familiar with, but a language, let's say like Ada, you can't just go around and cast things. Type conversion has to be done in a very specific way, in a very restricted way, to give more information to the system. Exactly how many bits and bytes make up a piece of data? Where is it? How do I treat it? What are the semantics of that data? So I just can't leave that up to the discretion of a developer. Casting errors are actually one of the top two errors that happen in a lot of programming languages, in a language like C, that and memory management, because people misunderstand the rules for doing it. All right, and that's directly related to the notion of type checking. Additional things that could be on your checklist: hey, I don't initialize variables very well, the names of my constants, what my loop conditions are, the logic I was talking about. Again, these kinds of things should be on a checklist of both you individually and also perhaps of your team and your system. If your organization knows itself well and understand how it writes software, it probably has an idea of what kind of defects are coming out of the entire team. And that's part of process improvement of the inspection as a whole. Okay, anyway, a lot of asides there. But what are the benefits of formal inspections? First is, as I talked to you before, the data shows that formal inspections find the most defects. They're just proven to find and help you reduce defects, and there's no debate about that. All right, the empirical evaluation shows it time and time again. Forcing one to prepare for a meeting provides motivation to improve quality. We tend to be deadline-driven people, as you as students know, which means, if you're given hey, my code's going to get reviewed on the 15th, chances are you're probably going to spend maybe a little bit more time than you usually do on the quality aspects of your time, because you're going to be hauled into a room pretty soon in front of a bunch of people asked to answer for a low-level quality of it. All right. And other benefits: visibility and openness of quality issues. I mean, you get people together talking about things. It creates an open dialogue about what the nature of quality is in your organization. What are some of the drawbacks? Well, it's socially distressing. I mean, the more formal we make things, right, the more, sometimes it puts people at unease, if you will. As I mentioned before, just a few minutes ago, a lot of times employees in that level of formality worry that, is this really about reviewing the code or you're reviewing me? And is this going to show up in my job performance review? And of course, if they think that, then you're going to have, then this is going to be tied to that. You're not going to get as much of that openness benefit if employees are worried that it's going to be some part of, I'm going to get fired, I'm not going to get a raise, or I'm going to get promoted, and so forth. And honestly, I wish I could say that that doesn't happen in the real world, but frankly, it does. Hopefully, in your organization, it does not, because this is a tremendous benefit to the organization. Other drawbacks: different participants may have different perspectives on quality. And this one is kind of humorous. This is kind of the classic. I don't know that I've been in a code review, a detailed code review, where two of the reviewers start arguing with each other, not even talking to the author of the code. They're starting to argue with each other about, really detailed quality concerns. I mean, the classic one is the argument over where the curly braces go, on the same line or at the end of the previous line, right? Do I write my code if blah, 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 curly brace here or curly brace there? And I've seen developers shout at each other over the curly brace issue, right? And that's just one example, but at a low level, a detailed level, there may not be one universally objective view of quality code. And socially speaking, folks can be more or less, kind of forceful in their push to promote their perspective of quality and what they think quality code looks like. And so that brings in another form of that social distress we're talking about, and doesn't even necessarily involve the author of the code. And then finally, the biggest drawback, though, I can't emphasize enough, I've already talked about it a couple times: scheduling and cost. Cost in terms of time, scheduling in terms of the formal inspection says that this is going to be a synchronous, co-located meeting with a bunch of people, so you got to be able to schedule it, right? And if you can't schedule it for a while, they may be holding up developers from moving on past that code or code that depends on it because it hasn't been accepted. It's part of your quality policy, yet the review hasn't happened yet. What do you do when you want to build on code off of that? What if the code I'm building off of hasn't passed review yet and has to be taken out, and I've already started building new stuff on it, right? So there's scheduling can result in a different kind of cost called the cost of delay. And that's, again, from an Agile perspective, part of the reason Agile isn't really into formal inspections. It's not, I don't know if I even say Agile's against the cost part of it, meaning if you can show me that it's worth the time to take 10 developers and put them in a room to improve the quality of that code, Agile would do that, and it will call it a spike, right? Where the team's going to stop and all review this code together because it's that important. And frankly, I can show that it's a cost benefit because the cost of having poor quality in that code outweighs the immediate cost of having this spike go on. Okay, but Agile definitely says, hopefully you're getting a sense in our Agile discussions. Agile is against standing still. You're always in motion. You're always trying to maintain that rhythm and cadence. And you have a real delay cost if things stop on the Scrum board because I can't move it to done because I'm waiting around to get all the people in the room to do some kind of formal inspection. Okay. Next one, team reviews, next on the spectrum, right? So this is sometimes referred to as inspection light. It's similar to our formal inspections, but again, now we're going to sacrifice some on formality. We may skip the overview steps and the follow-up steps. We may still have roles, but those roles could be more loose, right? These roles that we saw up in the formal inspections are very well defined. We may even have a separate reader, right, and a separate scribe, and a chief moderator versus the moderator, and so forth. So, we can be a little bit more relaxed in the role definitions and the overview and follow-up phases, but we still want to focus on it's still a team review, meaning we still want to get folks together and focus on that inspection process. So the goal is still quality, all right? And again, we've been talking about quality, so forth. We'll talk a little bit later how there can be other goals to some of these reviews. But the goal is still to find the most defects as possible. But we're trying to lessen the overhead and those social challenges. Again, lessening the overhead means, less dollars, less delay, less cost, less dollars. So we're trying to we're acknowledging we may find fewer defects, but we're trying to find some kind of equilibrium. We're getting kind of the most bang for our buck philosophy, right? I'm able to pull these off faster. I'm able to get people in the room. I don't have to be as formal. We can move a little bit quicker on them. So it's going to cost us less, but we're still going to find most of the defects and the important defects that we need to find, but we're acknowledging without the formality that we may not find all of the defects that we found with a full formal inspection process. Going down the scale toward more informality, then we have walkthroughs, and walkthroughs are common. They're talked about in the IEEE standard and McConnell as well. In this case, that developer presents the code to a small group of peers. So we went from a role definition to now it's going to be peers. We're all developers in the room. The developer, the author, we don't have a separate reader. The developer is going to walk us through the code, describe how it works, and the nature of the commentary and questioning is going to be freeform. Usually, this happens in a small conference room. Somebody puts it up on the board. The developer walks through, kinds of read it. You try and keep the social stress down. You try, you joke around about it and so forth. And it can be part mentoring. All right. So one of the things it says about this is the purpose is to benefit the author. This is, yes, you're going to find defects. There's going to be a quality benefit to the team and the code, but in a sense, you're using this collective behavior, many eyes, many minds, in order to teach the author. The author should walk out. The writer of the code should walk out and say, there's things I need to improve upon. I didn't do this, I didn't do that, maybe I didn't look at the design. The freeform commentary says it may not just be checklist driven, but it can be any kind of commentary, and sometimes a developer will state and say, here's a way you want to do it from this design perspective. I've seen these kind of meetings with the walkthroughs where a lot of times a senior engineer will stay after to talk with a junior engineer and help them interpret what they just heard, maybe give some additional detailed feedback. But didn't want to do it in front of everybody else, didn't want to embarrass somebody or make it sound, too rough, if you will. So, this informality kind of backs us up and allows that kind of communication to happen, while emphasizing our collective, we all own it kind of thing, and we're trying to help each other out, kind of approach. We're still getting a benefit to quality, right? But it doesn't necessarily address the quality needs of the project. In other words, in your quality policy, where it says we need to make sure we've looked and inspected for or audited for certain types of defects, casting errors, memory leak errors, code comments, you name it, whatever's on the checklist. Well, you're not checklist driven, you're free form, so you may not necessarily be able to walk out of that meeting and say, this passes. I mean, what does it mean to pass now if you don't have a specific set of criteria to measure against? You can say it's been reviewed, but how do you know it's been reviewed? And you can talk about the discovery and absence of particular types of defects if that wasn't what was driving your review in the first place. Okay, and then finally, talk a little bit about pair programming. And again, this was become popular with agile practices. Basically said, if reviews are good, if you're saying that this is the number one quality technique, why are we scheduling them every so often and going through this big formal thing to get people together? If they're good, let's do it all the time. Do it all the time literally means that you're co-developing, right? Two developers, one single computer, and you're alternating between the informal roles of driver and observer, right? And in a pair programming setup in a bullpen, folks that really truly do pair programming actually set it up in a team station where they have a keyboard. You guys can't really see, but they'd have their keyboard on a swivel between two people, literally on a little those things that pull out from your desk with a keyboard. They'd rotate it. We actually had a group of students years ago go to Intel where they had built a bullpen with these pair programming stations. So you can be alternating between driver and observer in real time, if you will. In fact, at the Agile conference 2 years ago, there was a presentation, and some folks who are on the bleeding edge have started to address or do something called mob programming, where I heard mob programming, and yeah, you could think mafia, but that isn't what I thought about. You think of flash mob, right? Instantaneously, we're going to get together and everybody's going to code together and they all have keyboards. Really, more mob programming is kind of one keyboard, many hands, not just two hands. getting together and doing the programming. And sometimes these sessions would go on all day long and would involve even different stakeholders. So, if feedback is good, if we want to react to change, and our weapon against change that always happens in software development is feedback, then we get the feedback constantly. We get it as we're typing the code in. Pretty extreme, but if you believe in the philosophy, that's the natural limit, right? What else is going to what else embodies that than doing it in real time, if you will. Some of the benefits to doing something like pair programming: continuous improvement to design quality. So it's not just the low-level coding, each line of code, but normally what you're talking about are different design quality, low-level design quality issues. So for example, we're going to talk about design patterns and refactoring in a few weeks. And so as you're typing, you might say, oh, here's the next programming task. I really need to figure out a way to instantiate and manage the life cycle of this object. And, your observer might say, well, what about the factory pattern? Right? And come up with that idea. And so you're always, looking at design issues, low-level design issues, or sometimes, design patterns, coding idioms are called. So instead of walking into an informal walkthrough or team meeting where somebody points that out after the fact, somebody can actually flag that as you do it. They can walk you through and work with you as you're doing those low-level design decisions. Mentoring and training. There's plenty of literature as well as the composition of the pairs. Should it be a junior and a senior engineer? And if it's a junior or senior engineer, who gets the keyboard more? Who's the driver and who's the observer? Should it be two peers that are relatively the same level? Various studies on the effectiveness of different groups. Folks always kind of thought it was junior and senior, but actually they're finding a lot of folks have found that putting peers together actually works the best. It can improve morale. That whole notion of that collective quality culture. If you're doing something with somebody and you're collectively responsible, then and you can show that improvement in real time. In other words, instead of the social stress of getting up and having to defend yourself, no matter what the level of formality, now you're doing something with somebody. You're getting the feedback in a non-socially distressing environment. It's going on all day long, so it tends to raise morale a bit. Better and more consistent discipline and time management. The fact that you have to manage your work together with another individual, literally sitting right next to you, usually means you show a little bit more discipline about what you're doing. You don't take the extended coffee break. You don't run out to the Starbucks. You're not late getting into work. You're kind of there prepared to work and mentally engaged all day long instead of sneaking off and looking at your Facebook 10 times a day. And there are fewer interruptions. You're already sitting there working with something. And there's a couple things from that. One is you don't have to interrupt somebody else like, hey, Susie, come over here for a desk check. At the same time, someone is less apt to come up and interrupt two people than they are to interrupt one person. If you're sitting there pair programming with somebody, it's less likely that, Susie's going to come in when Bob's sitting next to Kevin and Susie wants to talk to me about, how the Cardinals got crushed last weekend. She's less likely to do that because I'm sitting here working with somebody else, right? So small, minor optimizations to it, if you will. Some drawbacks, there are some costs. Tutoring time to get up to speed on the practice. You may not see the cumulative benefits. Now, there's kind of a common sense reaction to pair programming that says, well, if you have two people at a keyboard, right, management says, I'm paying these guys, and developers make good money nowadays. It seems like by putting two people at one keyboard, I'm not getting the same return on my investment in labor. Whereas studies have tried to show that you actually get a better return because of the way they're helping them out, and because you don't have the quality issues that come up later. All right, has that convinced industry? A lot of places are doing pair programming. I would say most places are not, and they go to more of an informal review like a walkthrough or a desk check. So some folks just haven't bought the economic argument of it, if you will. One thing studies have shown is if you do pair strong developers together, that likely they're strong enough where they're not seeing the benefit of this continuous feedback. Certainly there are some pairings that won't work interpersonal, but that's, human nature, right? No matter what the social setting is, some folks may have different egos. They don't work well in pairs. They want to dominate the conversation. They may have some annoying personal habits you don't want to be near, and some other work style or conflicts. In a professional environment, not supposed to happen. However, people are people, right? Um, and again, pair programming is one practice as opposed to inspections as a whole across the life cycle. Pair programming has only been applied to code artifacts, right? So in other words, pairing up people to work on some of these other life cycle artifacts really hasn't occurred. It seems to be a code level activity. Okay. So the summary from the Weigers paper of different ones. We didn't talk. I mentioned desk checks, but I mean we didn't cover those in specifically or an ad hoc review, which is basically you make it up. But the Weigers paper and book that I refer to that you'll read part of talks kind of gives you this summary of the phases, again, planning, preparation, whether you have a meeting, whether there's a follow up on the correction and verification, as well as some of the roles and characteristics of each one of these things. I do want you to have kind of a comparative basis to understand the benefits and drawbacks in general of more formal versus less formal. Because this spectrum, I mean, there just isn't one right answer. It has, we will talk we are teaching from an Agile perspective, and folks are predominantly going to Agile. Now, Agile's formal philosophy, by the way, the actual philosophy of Agile would say, like it says for a lot of things, we'll do as much review and inspection as is necessary and no more, right? And from an Agile term, they will talk about ceremony. So this is another one of my asides. I'm going to talk a little Agile for a second. In Agile, there's the notion of ceremony. Ceremony is a derogatory label applied to anything that is done that doesn't tangibly benefit the software product. All right. If it's done as an extra thing, then it's called ceremony. Right. The whole pomp and circumstance of it. So Agile doesn't actually say don't do a formal review. What Agile says is do as much as a review as is required for your product, but no more. If you're doing more than that just to punch the box and say we did this formal style review, then in fact you have ceremony and you're wasting your time and your money. Okay, so while people say, "Oh, you're doing Agile, you must be doing pair programming," not necessarily. In fact, I wrote a paper myself back in 2011 about Agile in safety critical software. We're working on an open source image guided surgical project, and part of the point is when it came to reviews, how much review is required, because if you need that thing to get certified by the FDA, or if you're working on an airplane or whatever, whoever has to, it's regulatory approved certified software, then pair programming is not going to cut it. I mean, you can't go into an FDA review of where software is considered a medical device and say, well, we did pair programming, or yeah, I did a desk check or a walkthrough. They want to know that you've audited it and you've tracked and you've traced. So there is more formality that's required. Does that mean you can't be Agile? No, what it means is some of these things that are associated with Agile practices you can't do. Agile would still say, well, if that's what you have to do, you have to do it. Okay, enough from that perspective of that aside. Let me get this ink off of here. I do want you to be familiar with a slide like this. Let me make it clear that this is something, this kind of trade-off, and that's why I put it on here. You need to understand the trade-offs, and again, most our trade-offs were mostly time and money versus level of quality. We also talked about it as well, though, from the level of the benefit of the author, the social distress. So I want you to know those aspects as well. Okay. So summary, I made up my own top 10 tips. I'll read through. I'm going to spend time on a little bit more on the bolded ones. And we'll do this as wrap up. So the first is inspections. I mean, can't say it again. This is the number one best technique for improving software quality. So you got to do the reviews. You can't just skip them and say, I didn't have time for that. You got to do them. All right. Now what you do, okay. Don't tie into the employee review process. We talked about that. You really shouldn't do that because you won't get that openness and honesty and transparency to the process. Doesn't mean it never happens. Unfortunately, no. Clarify the objectives and the level of granularity of review. And I even want you to do this in your projects. Sending a Slack message or an email or a GitHub issue over to somebody on your team and saying, go take a look at this. Yeah, you could say, oh, I went and read that code, Dr. Gary, so I'll sign off as I did a review on it. But really, you should understand what the objectives are. of the review. Is the objective to benefit the quality of the software? Is the objective of the review to benefit the author? Maybe you're doing a review so you can understand the software that I assigned to you for your class project. And then know the granularity. I mean, are we going line by line through detailed, one single class file, let's say, and going through line by line, and we're going to debate those curly braces and so forth? Or is this more of a, well, let's go through several classes and understand your application of a low-level design pattern, like the factory pattern, and whether you did that right. And, I'm not going to ping you on where the curly braces are in the code style. I'm going to leave that to automated tools that we'll talk about next. Have coding standards in place first. So there has to be some criteria. Especially if you're going to do a detailed code review, you need to know what the norms are for your team. They need to be defined ahead of time. You need to know what I'll put it this way. You need to know what your quality policy is. And I talked about that with source code control. When something makes it to master's software, how much unit testing should you have done? How much static analysis? How much code review? You should understand and know the criteria ahead of time. It's not, this is not a check the box approach to software saying, oh, well, I went and reviewed something, some low hanging fruit somewhere, and I can check a box, right? One is I don't want that in my class, but in real software development, the purpose isn't to do it just to say you do it, all right? That again is ceremony. The purpose is to achieve a quality objective. And the reason you have checklists and standards and a defined process is those things are supposed to help you achieve that defined standard, that quality policy. Okay. Keep it fast and light. Don't sweat the small stuff. That's a personal tip. I found that code reviews, again, I told you, where you're arguing where the curly braces are and so forth, aren't usually worth the argument that happens. Usually, I'm trying to go reasonably quick through the code, and if I have clear objectives on the granularity of it, to keep it moving. I mean, I'll put it this way: what happens in some code reviews, the reason why I have this on here, what happens in some code reviews when I was in the industry is, instead of talking about the code in front of them for the benefit of the author, folks started having debate about the coding standards in the first place. Right? The curly brace argument talked into an argument about the team style guide. Right? If you don't do a process improvement activity while executing the process, take that offline. Make a note, hey, I want to go back and meet with the team or mention in our retrospective that we could be better at these code reviews if we adopted this as part of our standards, and talk about it then. Don't talk about it in the walkthrough meeting, let's say. Okay. Specifically, look for things your unit tests and tools won't find. Unit tests, your black box and white box you just did. Tools, we will again talk about static analysis and so forth. So, for example, I don't think it's very worthwhile to spend developer time reviewing for coding style guidelines, whether or not you commented this line, whether or not you went over 80 characters per line because you can't print it out, whether or not the curly braces were at the end, or we'll see. You can run code stylistic checkers with those rules built in that can flag this stuff. And you don't need it to waste a human's time. Use the human brain, your peers' brains, to talk about things, and don't sweat that small stuff again. Do as part of a quality policy, not as a milestone. Again, that just goes back to, don't consider this a check the box. This is part of a quality process to achieve a quality standard. Track how many defects are found and removed. And again, even for all the way down to pair programming, but so sometimes folks with the informality say, well, I'm just going to fix that on the fly, or they'll write it down on a sticky note, right? Tape it to their monitor or something. I'll get to that by the end of the day. No, when no matter what level of formality you're in, track how many things you found and how many get removed. And for you guys, what that means, and what should mean for teams and industry as well, is go to your GitHub and make an issue out of it. All right. In GitHub, you have issues, and you can create an issue, and there's a labels. Looking on the right, there's a label setting, and there's a built-in label for bug. Right? Or you can create a custom label that says, code review found or something like that, right? And then go create your tag a task for it, right? Any change to the software that's required. So you want to get an understanding of how well you're doing at these reviews, as well as you don't want anything to slip through the crack. One of the most frustrating things is to go to a code review and realize you had a code review last week on related stuff, and this person's making the same errors, or errors that were supposed to be fixed by then are not fixed, which means somebody needs to follow up. Right? Somebody needs to make sure it's happening, and that the fixes that were asked for are done. So if you if you do a code review, let's say pairwise, and Bobby's supposed to go change some code, well, Susie better go check at some point later. Maybe she gets an automatic notification from GitHub saying some code was committed against that issue. Okay, but Susie should go check real quick that the fix actually happened and somebody isn't just waving it on through. All right. And then finally, this is the other big one. Prioritize which code to review by complexity and by how often it's used, how often it's invoked in the system. Like path testing and white box testing, if you want perfect quality, you would path test, and you would also code review every single line of code. And you would code review it if you want to optimize that quality dimension. You would formal code review every single line of code in the system, right? But you can't do that. And even for informal ones, even for walkthroughs, desk checks, pair programming, you really can't do that for every single line of code in the system. So you have to prioritize, and the prioritization of your quality activities goes for almost all the things that we're going to talk about. You can't unit test all the code. Well, actually you can, but when you recall how much effort it is to do boundary value analysis, equivalence partitions, to do all the natures of edge and branch coverage, let's say, or condition coverage, it becomes orders of magnitude more work. Same thing with code reviews. You can't. It becomes it slows you down too much. Becomes too costly. You have to understand, what level of quality your software system needs to be at for the domain of your application, and you need to unit test it and review it to the level appropriate, and that's why that level appropriate needs to be defined. That's why you have a quality policy. That's why you define it in measurable terms. And that's going to go for the rest of the things that we do. How much time are you going to spend refactoring? How much time and what rules are you going to invoke for static analysis? Are you going to pay attention to software measures and metrics? All these modules we're doing, this question applies. Prioritize which code to X quality practice, and do it by what's the hardest stuff. The hardest stuff, because that's where the most bugs are likely to show up, and also the stuff that's invoked the most, right? If it's something that a lot of the other code depends on, well, there's going to be a lot of invocations. Somebody's been calling that object or that method a lot, so maybe that's where we should prioritize and do our quality activity first. Okay? You can also do it by having a history or a track record. I mean, when you have a package or a component that's been buggy and you start finding a bunch of bugs in it, again, just like we said in testing, testing does not show the absence of defects, it only proves their existence. If you have a history of finding, hey, this is a particularly buggy component, well, guess what? There's probably more things in there, and you need to prioritize looking at, somebody just went and changed that logging routine. We've had a lot of problems in the past on that. Need to go in and code review that one. All right, that kind of stuff. Okay. So again, in summary, code reviews, the number one things to do. So do them. Do something. Follow up on it. Okay, and this is going to be required of your projects going forward, and the nature that you do them. And again, your level of formality, I'm going to leave up to you. I'll give you some tips over in our Agile talks about what you can do. Certainly for online, you're in a special situation. You may not be able to get together synchronously. So how can you do them asynchronously, for example? And what processes can you do? And are there times when asynchronous just isn't going to be good enough? You really want to get the person on the other end of the line, in a Google Hangout, a Skype, a phone call, a Slack messaging, or something like that, or sometimes even one of these synchronous code editing tools. I'll talk about that as part of the Sprint Agile approach to things in that lecture. Okay, that wraps it up for code reviews.